In this video, we will go over the system testing to prove FPGA layers generate the same output vector as CPU and the GPU. So we are going to prove this requirement over here. To do so, we are going to use the Cafe test bench generating the data, and then have that data creating the SCV header file to run that against our FPGA implementation. So to prove that, first of all, we are going to go over the code of the Cafe. As you can see here, this is the Cafe code from the Cafe repository that we just basically cloned from Cafe GitHub. On the left-hand side is the template that Cafe defined for the convolution layer. That layer define of the parameter for test benches and have of the setup of the stride of the padding of the parameters that being set here. And then later on in the Cafe code, as you follow the cursor on the left hand side, you can see that they actually went in and do all of the computation in here to make sure that it is matching the output, and including of the computation for the bias, doing the convolution from the throughout the convolution layer. So to make sure that we obtain the same input data, I have modified the Cafe code such that every time the convolution function on the left hand side is being invoked, those data that is being generated is also get parsing out and pipe into a system verilog header file. That way we got the whole vector array that we can use to test for FPGA design. So on the right hand side, these are some of the functions that I have created and added to the Cafe code. So in this one, it's basically creating the system verilog header file, and as you can see, it's creating all of the defining for the testing for the convolution layer of the parameters, and then it parses off the data. And later on, there are other different functions that basically go in and fetch each of the computation through every step that convolution layer is being done on the Cafe code. And then at the end of the day, it will be outputting into as a file, namely convolution forward testing Cafe with some number of the test bench afterward. So right now, to have Cafe code generate every test bench and test cases, we are going to run the Cafe make file here by using the command make and then test. So this one would allow Cafe to populate all of the test benches, and that's going to take a while. Okay, as you can see here, we have successfully built the test cases. So now what I'm going to do next is actually to invoking to run off those tests here by typing the command make run test, and the test should be running here pretty soon. And there we go. So as you can see, all of the test cases has been run, and Cafe against the FPGA has been run successfully. As you can see, the run and OK here through all multiple layers. So now the test cases, as you can see, it has successfully run through convolution and scaling layer, and now it just keep going. And if you look into the directory here, different directory, or in the Cafe main, you can see that it is actually generate .vh file, which is basically the header file for all of the system verilog that we can use to test against our FPGA implementation. And for example, you can go into convolution. Let's say what's the lucky number today? 15. So if you look in here, it's actually generating all of these parameter test cases, and that's basically the output, and it's actually matched with our implementation result. Thus, it has proven that FPGA implementation and execution actually match the output of the CPU and the GPU implementation. Thank you.